All right. How's everybody doing? So we have a very special guest today, Renaud from Malcat, who reached out to me not too long ago just to see if we could showcase this awesome tool. And I just want to let Renaud give us a bit of background on himself and Malcat.
So, hi guys, I'm Renaud, yes. I'm the main developer of Malcat. During the day, I'm a developer in, basically, I develop software for the anti-malware industry. I work for an antivirus company in incident response, doing mostly research and development. But during the night, I'm the developer of Malcat, so a small tool that maybe some of you know. So whose goal is to help you, fellow reversers, triage and analyze malware more efficiently.
Cool, awesome. Yeah, so today we are just going to look at a few different malware samples, a few different file types, just to get a handle on what this tool does. But from what I've seen thus far, it's essentially a hexadecimal editor or hex editor like 010 or something similar that you used in the past, but on like super steroids. So it has a whole bunch of different malware triage functionality built into its various views and interfaces, and it allows for basically rapid triage of multi-stage malware infection chains with the ability to integrate your own Python scripting. It has a whole bunch of different integrated tools that are used to detect anomalies within the different file types that folks typically analyze for malware analysis, et cetera, et cetera. So I'll be getting Renaud to help me with some of the steps in Malcat since I am new to the tool, but yeah, it's pretty straightforward. So I'm going to be steering today. So I'm just going to open up a file here. So upon opening Malcat, you'll just see this user interface. This is the Malcat professional version. So this just has a few different features. Do you want to just touch on some of the different types of licenses that you can get?
So you have a free edition that is still pretty complete. I mean, the things you will be missing are just, it's limited to x86 and x64 for the disassembler part. And you won't have access to Kesakode and the anomalies. And maybe one or two details, but with the free version, give it a try. I mean, it's already pretty complete, and you can do a lot with it, achieve a lot with it.
Cool. Yeah. So if folks want to follow along, maybe I can pull up the Emotet TrickBot analysis for this. Let me just, or the files rather. Let me just grab that real quick. I should have had that ready, but that's okay. And then I'll throw that in the chat. But yeah, these are the files that we'll be working with. And then you can grab those files on malcat.fr, or grab the free version rather, not the files, the install files that you'll need. And then you should be able to follow along with most of the steps that we'll be going through, because we are looking at x86 binaries. And then do you allow processing of Maldocs as well in the free version, or?
Yes, but you won't, since you won't be able to decompile the BBA, for instance, because it's another architecture. But yeah, you can. The hex editor is complete in the free version, and you can unpack stuff. You can script. You can decrypt stuff. You can do almost everything.
Cool, nice.
Just a quick note before we go on. Malcat is currently in beta phase, so it's a beta that started 3 years ago. So it's a long beta. But just so that you know, the final version should come soon. But I still consider the software not completely finished. I mean, it's used a lot by many people for many years now, but still, you may encounter a small bug or something. Things like this when using Malcat. Just keep it in mind. It's not a completely finished software. It will be soon, end of the year, maybe beginning of next year, but not finished.
Cool, awesome. Okay, yeah, so let's open up a file here. So I'm just going to click on Open File. And then I just copied some of these files that I was messing around with beforehand into a different folder. And we're going to start with, so this particular infection chain was for Emotet. It's quite old. It's from 2020, but this is a really good illustration of the multiple different file types that Malcat can handle. So I figured this would be a good example to look at. So I'm just going to open the Maldoc here that was the beginning of this infection chain. And as you can see, there's a whole bunch of different information that was just presented to us in the interface here. So at the top of the list here, or the view, we have file information. So this just gives you a breakdown of various things that we are looking at in this interface right now with this particular file that was just opened. So of course, the file name, its size, the various hashing algorithms that were applied against this particular file. Obviously, imp hash is not applicable because this is not a portable executable. And then we have various metadata attributes that were extracted from this specific file type, this being a Word document. And this is a OLE Word document, I believe. So it's funny, this Melissa Roussel, I think this was built with a builder, because I remember looking at these. I used to look at a lot of malware documents back in the day, and I think this was a builder with that particular author name. And then we can see that there is an embedded VBA project, so that does indicate to us that there is likely some form of Visual Basic application code within this. And then we have the character encoding, which can be important in some instances. And then there's a whole bunch of different other things here. So Kesakode, do you want to just touch on Kesakode, and then we'll kind of get into it more nitty gritty later on, just because I don't want to leave this out because it is important.
Yeah, sure. Kesakode is our function and string signature service that you get for free when you have a paid version of Malcat. So basically, think of in Tether, they had a service where you could identify malware by submitting it, and they had these nice function signatures. It's kind of the same, just for poor people. So that's a poor people version of Tether.
So what kind of algorithms do you use for the function identification? If you want to, if it's custom, don't worry about it. But
no problem. I mean, it matches on 3 different levels. You have functions. For functions, I will typically mask out everything that is an offset to make it position independent. It will also hash strings with some prefilters, and also all the code immediates.
So if we take a look at this report, we continue on here, we can see these anomalies. So these are custom Python scripts that are built into Malcat. So under this anomalies area, this will basically run a bunch of scripts against the given file type, and then any anomalies that match will show up here. So for example, if I look at this cfb.py, and then we can see that basically this looks for the analysis parser VBA modules, and then it yields whether or not a VBA module exists. So there's a whole bunch of these anomalies, and they're actually super useful for when you're doing triage. I'll go into a few more of these. You can kind of think of these like, I believe it's here too, like Kappa, where you have those YAML definitions, but I kind of like them better than YAML definitions because they are written in Python. So the anomalies are really cool.
Yeah, so you can compare it to the heuristics of an antivirus. I worked pretty long in Yara, and I was in the heuristics team, so I got my inspiration from there.
Nice. Yeah, that's super cool. Will you show... So I'm just looking at the chat here. I'll probably keep an eye on the chat, and then I'll just repeat the questions to you, Renaud, since you're not watching the live stream.
Yep.
So Hexamine says, will you show the case where the dynamic jump calculation in CFG recovery? Any ideas?
How do you want to showcase it? I made a blog post in the last for the last release.
Oh, cool. Okay.
Where I detailed a bit what I do. I think you can refer to the last blog post 0.9.10 release.
Oh, cool. Okay. Yeah.
Yeah, this one you should see some
UI improvements. Oh, control flow graph recovery. Okay, cool. Yeah, I wasn't entirely sure what
I don't go
CFG
that much in details, but you have the big lines there. So
is this CFG recovery? It's outside of SLAY, right? This is for your disassembler, or?
The CFG, well, I have disassembler, but then you need to know what is code, what is data, resolve all the dynamic jumps, the switch, and so on, and then compute the function boundaries. That's what I call CFG recovery. It covers the CFG and also the...
Okay, nice, cool. Yeah, I'll definitely need to look at this closer. Maybe we can have Renaud on again to look at some of these advanced use cases. This is kind of like a 101 stream, just to kind of get people used to some of the functionality in Malcat. But yeah, I definitely want to take a look at this because apparently, according to Hexmean, it's super cool and it's able to deobfuscate the main obfuscation in Luma. So that's pretty awesome. So, and I know, yeah, Luma's a giant pain. So, okay, so let's get back to our sample here. Again, this Maldoc. If we look at the left-hand side here, we can see there's a whole bunch of carved files outside of this particular file format. And these are under this virtual file system. The carved files are not, but then there's a whole bunch of stuff under the virtual file system for this particular file, which we'll take a look at in just a second. But I just wanted to touch on these carved files. So if any of you have used tools like binwalk, or there's a whole bunch of different things that do this, different projects that do this, but I found this to be extremely useful because if you have a whole bunch of embedded content within a particular file format, then this will carve out those particular file formats and then provide them here. So in this particular instance, we can see that there's a JPEG embedded within this file format that was carved. And then if I click on in the left-hand side, we have this little viewfinder that shows the image. But if I click on zoom here, then we can see that this is a typical social engineering message that you would see within a malicious document. And it basically says like operation did not complete successfully because the file was created on an Android device. To view and edit the document, click enable editing, and then enable content. So this used to see this a lot with these Microsoft Word documents. Basically, they wouldn't enable this Visual Basic application code by default. And then you would have to click these dialogues in order for the VBA to be enabled, execute, and then they would use this to execute various payloads, follow-on payloads, etc., embedded payloads, whatever. We'll be looking at some code that's executed by this document today, so that'll make it more evident. So I just wanted to show that, which is really useful. And then on the left-hand side here, we can see that Malcat was able to fully understand the file format and then extract those Visual Basic application macros. So if I open up these tree views here, then we can see there's a whole bunch of sub objects here that it has extracted, or I guess sub files within the virtual file system. And then if I go to...
Just a quick note, this format used by Microsoft, it is exactly a file system. Actually, it's a FAT32 file system with an expandable, FAT32 file system. It's really an ugly format, actually. It's a disk image.
Yeah. I remember looking at, I didn't really look at it in depth, but I know OLE, I did a workshop at DEF CON in like 2019 on analyzing what I call like these document exploit kits, which were basically RTF documents with multiple embedded OLE objects. And then it would load those OLE objects sequentially. So then if your system was, say, vulnerable to like those equation editor exploits, then it would like load that first and it would hit that exploit first. Or if it was not vulnerable to those, it would keep loading the OLE objects. So then like the last one was like a flash exploit. So it was pretty cool. Obviously, all those are not really a thing anymore because people don't really... I know there was some O-days recently for Word, so I think it'll always be vulnerable to stuff. But yeah, anyways. Oh yeah, so getting back to what I was talking about. So yeah, this is what turns out to be a real file system, FAT32. And then these are the embedded objects within that file system effectively. So if I look at the right-hand side here, we have a drop-down that provides us various views. So we were just in the summary view here, and me clicking on that image brought us to the hexadecimal view. And then if we look at some of these other views here, we have like structured text. So do you want to comment on what you're ripping out within the structured text view? I didn't really look at this too closely.
Yeah, in this view, you will have all structures that have been identified. For instance, if you scroll to the top of the file, maybe we will see a bit more what I'm talking about. Yeah, you will have all the structure fields expanded, and everything that is not in a structure will be displayed just with text. So if you are looking for text or for structures, that's the view we use.
Yeah, so if we look at the portable executable later, then it would have the MZ header followed by the PE header or whatever.
Exactly.
Right? Cool. And then if we look at the disassembly, this doesn't make any sense because it's a Word document, but we'll look at that a little bit closer later. But it's obviously tried to do some disassembly on those provided bytes. And then the proximity view, let's not look at that right now. But if I click on source code, this is actually going to provide the VBA output for this particular document. So as you can see, there's a big, ugly, embedded Visual Basic application code segment here. And then if I look at, I'm going to have to go back in my memory and fish out some of the functions that were used. But if we look at this private sub document open, so this is a function that's automatically invoked once the document is opened. And then it's calling this sub function here. So this within this GOF VBA, I think they're classes, right? These VBA classes. But if we look at this function here, I haven't written any Visual Basic in many years. So I just did Control F so we could search for this, and then we can see that this is the function that it's invoking. And if we do look at this a little bit closer, there is a keyword here that is quite important, and it's split. So usually, more often than not, I would use something like ViperMonkey to extract this VBA out and emulate it, whatever. But I want to stay within Malcat for this entire demo, so we could probably just mess around with this code directly. And this obfuscation isn't super complex. It's basically just doing a split on a given string and then joining it later in order to form a final string. So for example, if we look at this particular string here, we want to deobfuscate this, then we would split on that given string. And Malcat has what are called transforms. So if I open this up, so for any of you who have used CyberChef, this is very similar in that you essentially make these transform chains that contain various transforms that are available on the left-hand side here. So if I just open these up, we can see that there's a whole bunch of different types of transforms. There's arithmetic operations, there's binary operations, or bitwise operations. There's
they are all written in Python. And as with many things in Malcat, you can also extend it, write your own, and it's pretty easy to use it.
Yeah, so if I open up like this 8 XOR 8 here, or like a byte-based XOR, and then do view Python file binary.py, then we can see that this is the class definition here for this particular transform. And you're just taking it takes the doc strings and then puts it right here. So it's really nice integration into the UI. And then you specify a category. So that's just the little folder that it's under in the UI. And then we just have a byte-based XOR in which you provide a key, and then it's a rotating key XOR. So this is very common in malware, so it's good to have this type of transform. And then we have even things like circular adds, subs, ors, whatever, and then obviously these can be combined in sequence, and then like Renaud specified, they can be expanded upon or extended in order to meet your requirements. And we're going to do that with the portable executable once we get to that point. But for this particular obfuscation, on the right-hand side here, we have the obfuscated string with these additions here that was selected from this line. And then if I go to replace, which is another common thing that you do with a lot of malware stuff, and then scroll down to where that split was. Let's see if I could just find it again using this.
88.
And then copy that string. Then we're just going to replace this with nothing. And then we can see here that it is indeed constructing a WMI interface here. So it's kind of hard to read here, but it's like win management plus colon win32 process.
Yeah, it's most likely create process from to instantiate a new process, I guess.
And then, so this actually contains another section of the VBA here that's highly obfuscated. And then this is actually referencing an embedded VBA attribute, I believe, which has a big long string. And if we go to the hex view here and we scroll down, we can actually see that here. So there's probably a better way to get to it than what I just did, since we're looking at the raw hex view, but this kind of works. And because this string is so big, I'm actually just going to click that, scroll down.
If you want, you can also, because there you can see in the section name on the left, it's called Word document. So it's actually the content of the Word. And if you, in the virtual file system, if you double click on the Word document, then double click on this one, you can have a bit of more information. For instance, go into the structure view there.
Okay.
F2, yes, structure view. Yep. There you have some headers in a old school Word document with some stuff. And if you scroll a bit down, you will see your string again. And you will see that
Oh,
this
nice.
string, actually, it's a word user text. It means that it's exactly what has been typed inside the document. You know, when you see this, you know it's not inside a picture using steganography, inside a table. No, it's just what is typed inside the document. Most likely with, I would guess, with a white font, or maybe they didn't care at all.
Cool, nice. Yeah, so then if I don't even have to do the getaway that I was just doing before, which is like selecting, holding shift in that. I can literally just
But you have
click.
one extra byte at the beginning.
Yeah, yeah, it's not a big deal because I think with the word replace, it won't matter, right?
Yeah.
Oh, did just get rid of my little chain there. Let's see. Let's do a replace again, and then grab that string from before.
I mean, we can see it there.
How do I get back to?
I don't want to. You can. It's the button directly on the left of the where you are clicking.
Oh, this little thing. Yeah.
This one.
Oh,
yeah.
Okay.
It will close what you have. Yeah, sorry, I broke your flow.
No, that's okay. Okay, so I'll just go back to source code, and then I just need that little string again. I just don't want to copy the wrong one. Okay, so then we're gonna do the replace. I don't know why that's not coming up. It's because I dragged it to the bottom. Why did I just lose that other transform? Is it because it's selecting something else in the view, or what did I do?
Which other transform?
So basically, I just want to get back to that like big, huge word string.
Oh, it's because it was in another document. So just close and open it again and do from the beginning. It was because it's specific to the currently open document.
Okay, so then if I select, I have to go back into the structured view.
Right? No, it's there. It's this one. Yeah.
Yeah, everybody bear with me because I'm a giant Malcat noob. So we'll just do it that way so we don't lose that again. Transform.
You can hit Control-T. No, it's the old one. Close this one because you can only have one open.
Okay. That's probably what I screwed up. Replace.
No, you're good to know.
All right. And then if we look at the text here, then we can see that this is a big old PowerShell string. So basically it's executing the given PowerShell, and then this is base64 encoded. So is there an easy way for me to base64 decode this here, or do I have to open this somewhere else?
Well, you could cut the beginning and then add base64, but I think it's easier if you open it.
Okay. Yeah, so I just, with the output, I created a new file in Malcat. And then if I go to Hex, then we can just get rid of these bytes. And then now we have that. And then if I go to transform again, so transform base64.
Wait, you don't have anything selected.
Sorry. All right, there we go. Transform. Then we do base64 decode. And if we look here, we can see, okay, so now we have a whole bunch of obfuscated PowerShell that'll basically decode on the fly and then execute using our little PowerShell string there, or using our PowerShell execution there. So is there a way to clean up these null bytes, or I can just do like a replace?
Yeah, you can search for encoding.
Coding.
Change text encoding.
Okay. Oh, there we go. Okay, cool. So yeah, if I do text, then we can see here, there's a whole bunch of more obfuscated PowerShell, but we can clean this up pretty easily, again, using like text replace. So if we look at, this is very common PowerShell obfuscation. So we have things like, here, I'm just going to make a regular expression, and then we're going to replace, we're just going to actually remove all these characters. So it's pretty easy. And then I'm just going to make a character set that we're going to remove here, and we'll do carets because that's one of the obfuscation techniques. And then effectively, they're basically just concatenating a bunch of stuff together. So we could just do like tilde plus.
And you need to put it in quotes.
Oh, sorry. And then those as well, the ellipses. And then as we can see here, after I remove all of that obfuscation using the string replace, then we have these command and control servers here. So this is basically what's going to be downloaded from. And then we can see here that there is a .exe name that's being used here that is likely the area in which the file will be downloaded. So I forgot the, let's see, there's one more thing. We have the command and control addresses though, so it's not a big deal, but the backtick there, which is another obfuscation technique. Okay, and then, so yeah, say we wanted to extract these out, put them in our SIEM or put them in our IDS, IPS product, whatever, we could just move forward with that. So pretty straightforward for extracting those. So yeah, we went from a given Word document to deobfuscating the PowerShell to figuring out how it works. And then we extracted these steps within our malware triage process all in Malcat. So that's pretty cool. So then if I want to save these, I can. I don't think we'll need them later, but in case we want to search them, whatever.
You can just click to clipboard.
Oh, really?
Yeah, because there, I don't think that you have compiled. There is
to
two clipboard.
To copy it as text.
Yeah, it didn't identify it. Well, sorry.
Whatever.
Sure, bad advice.
Okay, so let's move on to the executable. So part of this set of files that we were given from our traffic analysis, we have a executable file. So I'm just going to open that. So I'm just going to go to open file again, and then Emotet.
Yeah, I think we wouldn't have gotten the hex files. I hope that they have been taken down since 2020.
Yeah, I'm sure they're down by now. So if we look at the card files on the left-hand side here, there's just like some DIB files, so nothing particularly interesting. But then all of these values have been extracted from the portable executable format of this particular Emotet binary. And then we can see that there's things like RC data, string versions, etc. So pretty interesting. But then if we look at the summary, then we get a whole bunch of different attributes now. So again, we get that import hash because this is a given portable executable format and has things like imports. We have a company name, which is blank. We have the compilation timestamp of 2020. So this is, again, an old binary, but that's okay. We have the file description of a zip test MFC application. So trying to look like some sort of zip application, et cetera, et cetera. And then if we scroll down here, we can see that there is a few different things like this fingerprint Yara signature that hit, various compiler signatures that hit, the zlib library that hit as well. So that could be important. Again, there's no Kesakode hits, but that will happen. Spoiler alert. And then
just a quick note for Kesakode. I mean, there are signatures for plain text malware. So it's completely normal if you don't get any hits for what I guess is a key or pack malware. Yeah,
so then if we look at these anomalies here, these are pretty interesting and really good to pivot off of. So we have like things like XOR in a loop. So if I click on that, then we get a bunch of output on the left-hand side here that basically shows us that there is some function references. So not only does Malcat have the ability to process these file types, but it also has the ability to disassemble them and decompile them. The decompiler is using Ghidra's Slay, right?
The decompiler, yes. Disassembler is homemade.
The disassembler is custom?
Well, it depends for which architecture. For x86, I use CDASM, the core. And for some, it's custom, yes.
Cool, nice. Okay, so let's take a look at some of these anomalies here. So again, XOR in a loop, there's stack array initialization. So if there is a large stack array, this one's kind of not very interesting. But if we look at many unique bytes, that is pretty interesting. If you had like particular segments.
To find crypto functions mostly.
Yeah,
or obfuscated code also.
Cool. Yeah, that makes sense because it would have many different operations sequentially, I guess.
Or arithmetic obfuscation.
Arithmetic operations, yeah. Okay, and then we have many high value immediate. I didn't look at any. Okay, cool. Do you want to comment on these symbols on the right hand side here?
This, I mean, it was a test that I did at the beginning of Malcat. I had a view, I think. No, it's deactivated by default. It's what I call the DNA view. It's to answer a given problem. I find some of the most difficult malware to detect are when the threat actors take a clean file, a huge clean file, and they just patch like one or two functions inside the clean file with a shellcode or Metasploit stuff. And that's pretty hard to spot, especially if it's buried inside the file. So to spot this, basically you need to go through the file and visually see if there is something odd. And the idea was to have a view, the DNA view, to have a view that would represent every instruction with one symbol. Okay, these are the symbols that you are seeing there. And you have this view in Malcat, but you need to enable it in the option explicitly because nobody was using it beside me. So I say, okay, I just remove it. But it was for this. So it was a view with one symbol per assembly instructions, and for you to help you to visually see when code was a bit different than the surrounding application. Like, oh, these two functions, they use a lot of add sub, for instance, the one after the other, where the rest of the code is more traditional C compile code, for instance. Maybe it's a shell code inside an application. But I've kept this one symbol per instructions in this commentary there. So it just gives you the prologue of the function. The first instructions of the function are represented. For instance, the first arrow, it's a jump. The parenthesis, it's a push. If you learn a bit the symbols, you can have a lot of information with this.
It's like a disassembly compression or something.
Yeah.
You just have to make it into memes and then everybody will remember them. So if we go back here, let's keep looking at these anomalies. And then spaghetti function, kind of similar, right? Common for obfuscation techniques.
Yeah, it's a lot of jumps. So,
and then we have one that I was waiting to get to. Go ahead.
Yeah, just a quick note. These anomalies there, don't see them as like antivirus detection. It's not clean or malware. It just, I've meant them as pointers for the analyst to have things to look at. I mean, you need to do the triage at the end, but it's good for beginners because they can go quickly to the spots that are interesting and maybe see some things that they would have missed otherwise. But for more veterans, it's just a few shortcuts, but it's pointers. It's not a ground truth that we would tell you, oh, that's bad or that's key.
Yeah, I already found them really interesting and useful when I've been doing triage. So even for somebody who's not a beginner, I feel like it's super useful, especially for those scenarios that you were talking about where there's like a clean file jumping to a shellcode segment, which is very common. I found those, this is very helpful for identifying those. So, or at least giving you a starting point to identify them. So if we look at possible Packer API dynamic imports, then we can see that there is a couple of interesting imports within our data section. So
this anomaly, just a quick note, it's when you have some APIs that is usually used by packers like virtual protects. Malcat sees that the string is in there, but it's not, the API is not imported. So it may be because the API will be dynamically imported using getproc address. It doesn't mean that it's a malware, but it's something that is used a lot by malware.
Yeah, in our malware analysis course, we have like a x64 debug script that just sets a bunch of breakpoints on common unpacking APIs. And then like we use that. It's quite a bit easier than one setting all those APIs yourself.
That's your usual suspects that you will find there.
So this is what the Python script looks like. Basically, there's Packer related APIs, and then is present in the binary, but they're not imported. So that's quite suspicious. And then we have the Packer APIs constant here. And if I scroll up, then we can see that kernel 32, virtual protect, virtual alloc, resume thread. Yeah, all these are very common. So if we look at some of these references here to those strings, so within the hex view, if I hit tab, then it brings up this legend or whatever, that's the correct word, the correct term. And then I can unselect some of these and select some of these. So say we wanted to remove some of the anomaly identification or enable them, then I could select that. If I wanted to remove some of the objects, I could select things like that. And in this instance, we do want to look at the... Go ahead.
And is that useful because you may have noticed that I like a lot of colors and information at the same time on my screen. But if you don't like it, you can configure it exactly like you want, have less information on the screen, and it will be safe too.
Nice. Yeah, that's cool. Okay, so then on the references here, we have one that is referencing loader find resource U. So if I select that, Ollie debug Christmas tree for the win. Yeah, totally. Yeah, for everybody who's used Ollie in the chat, shout out Ollie. It's a OG tool. Okay, so if we look at this sub here, we have a string loader access resource that's passed to this EDI register, and then this EDI register just has the address of a get proc address. So this is very common to see within Unpacking Code, where you have these functions being resolved at runtime, the addresses to those, and then they're being called at runtime. So if we look at where this function is called from, I can click on this, go to cross references, and then we can see that this is a cross reference to this other function here. And before I do that, I'm actually going to rename this to, let's just call it load resource. And then if I go back here, to that cross reference, then we could see that there is another interesting string here, and then another pseudo-random looking string here, in which this get proc address is being called for that particular string. So why would that particular string be called with a get proc address? So if I look back at the symbols here, we can see a few things. So we have the exports entry, and that string is contained as a given export entry. So what that tells us is that get proc address is being used to resolve a particular function within this DLL in order to call it. So if I go back here, then we can see, let's see, how do I get back to where we just were? Okay, let's go to that cross reference. Then effectively that export function is being resolved using get proc address here, and then that's set into this variable. So I'm just going to change into the decompilation view. Again, this is using Ghidra Slay just to make this a little bit more readable. And we have a whole bunch of different things here. So we have the get proc address for our given export. So suspicious func. And then we have the resource that is loaded and then set into this. So this is probably the resource data. And then this variable is being passed to virtual alloc. So it's probably the size of the resource. And then usually when you're doing triage like this, you can do some guesswork to see if you can get to the right answer before actually confirming all these things. But if you were to look at the definition for virtual alloc, then you would see that particular parameter was the size, I believe. And then, so this will be the, well, let's just call it valloc. And then that's being executed here. So what we need to look at is that function definition for the suspicious function that's being resolved using get proc address, because that result is being executed here within this call. So in order to do that, we can go back to that export. So if I just go to, so actually let's make note of a few of these things. Can I just copy this?
Well, you can Control C. Sorry.
Okay, that works. If I go back to the symbols and then go to the export and then go back to disassembly, so I'll just hit F4. You should make that F5, by the way, because that's like IDA. So, and then if we look at the export function here, then I'm just going to pull up my little function definition here. So the first parameter is resource data. The second parameter is, we don't know yet. The third parameter is the key, or what is probably a key. And then the fourth parameter is the size of that key, or what's probably the size of that key. If we look, it's like hex 28. So if I do something like this, copy that, open Python. I'm sure I could have done this in Malcat, but and then do hex 27 with a null byte is hex 28.
I hate when they do this. Like you find a string, you test, and you forget that sometimes they include the null bytes.
Yeah.
And you have just lost 10 minutes of your life.
And then this is doing the Ghidra Slay thing that I don't like, where it's I select a variable and then it doesn't stay selected, it doesn't stay highlighted. But this is the fifth variable here. And if we look at what this is used for, this is going to be the result of this XOR operation is being stored there. So this is probably the decrypted bytes. So I'll say PT bytes. or PT payload, because we know it's executed with that virtual alloc pointer. Okay, so we have this plaintext payload. We have a given deobfuscation routine. If I look at this 40F 4A0, 40A, sorry, then we can see that this is performing a malloc. So let's
just a quick note there. For instance, this malloc, it has been identified using flirt signatures. You can also use flirt signatures within Malcat to just store them inside the data directory of Malcat, and you can use your own.
Yeah, super useful. And if I go back here to where that was called, let's just say alloc1, alloc2, and then let's just say PT payload or pointer. Oh no, is that going to be, yeah, okay. So, and then we can see this value is being passed to this MW alloc. And if I click on this D here,
you need to control click, because there you are clicking on the reference. So if you just want to see the bytes, it's control plus click, or just hide the reference.
Control click does the right click. Let's see, can I turn off the reference?
Yeah, just turn off the reference, click on it, and then you will see the bytes.
Okay, cool. Yeah, so then we can see in the left-hand side here, this is an unsigned integer of that value. So hex 1F70D. And then if I go back here, so can I make a comment? How do I make a comment?
I think right click. I don't know if it's in this version.
You got it.
I don't know if they will be shown.
Okay.
Oh, okay.
And then we have the key size. This var is going to be the current index within this loop. So I'll just put I. And then within the allocation, we have the first value there. And then that's being used as an address. So basically this is just initializing this loop. So can anybody in chat tell me what this is probably doing, or what algorithm this probably is? Anybody? What usually does like an initialization loop with the count, and then does these swaps, and then does an XOR at the end. Anybody? All right, radio silence. So this is probably RC4, but what the difference is in this case is RC4. Okay, I just saw like 4 RC4s come in. Sorry if I missed that. My camera might have been in the way. Cool. So if I look at down here, then we can see that the difference here is that this while loop is being initialized with this hex 1F70D iterations. So basically that's making an S box of that size. And then, so if I just do S box, then that's what's being initialized here. And then if we see where else that's being used, why is it not used elsewhere, that particular variable? Am I going crazy?
I think they copied it somewhere else. I think it's, if you look, it's either alloc1 or alloc2, I think. Look, it's not S-box, it's S-boxed either. For instance, it's alloc1 is your S-box, and what you have named S-box is actually a pointer to the ith element of S-box.
Oh, sorry. It's just using this loop. Okay, so let's just rename this to A.
There.
And then alloc1 is the S box.
I think that's an issue I fixed in the last release. Yeah. You need to do it twice. It doesn't refresh immediately.
Okay, and then this is the current key byte. Okay, so this basically initializes the S box at first to the key over and over again. And then we have the swap operation occurring here. Again, for the size, for that given anomaly size or weird size for the S box. And then down here we have, let's see, doing plus hex. And then, yeah, down here is the actual swap, I believe. Yeah, alloc2. And then that's decrypting the plaintext payload. Okay, cool. So if we wanted to re-implement this, so I actually pre-baked this a little bit just because I didn't want you all to see me struggling over RC4. But if we go back to those transforms that we saw earlier, oh yeah, and then there's one more thing, like what is this actually decrypting, right? So which resource is this likely decrypting? If we go back to the summary, we can look at more anomalies, which is pretty cool. If we look at these anomalies here, we could see big resource, high entropy. And then if I go to this resource, this looks like encrypted data, right? So we could probably guess without looking up the resource identifier that is utilized by those dynamically created functions or dynamically resolved functions that this is probably the resource that's being decrypted here. So again, I kind of pre-baked this a little bit and wrote that RC4 algorithm. So I'm just going to open up transforms again. And then we can add a custom transform by clicking on this little plus button up here. And then it adds this custom class for us, but I'm just going to copy over that RC4 and just show you what that looks like. A little transform editor here. So again, very similar to something like you would do with CyberChef, but I think CyberChef is a lot more difficult to customize than this because I think it's written in JavaScript and uses NPM and stuff. But here we have a class called RC4-4C, and then we have our description here. So spoiler, we already know this is Emotet because of the description, but that's okay. And then we have the run function here that's defining the input parameters that we're going to be providing for the UI. And then we have like if not key, then return data. And then we have the SBox initialization, and then we have the initialization with our given size, which in this case is 128,781, which is that large hex value that I showed you earlier. And then we have the typical RC4 implementation, but within each of those areas in which that large SBox is used, we need to replace it with that given size. So that's basically the customization in this instance. So I'm going to click save and apply. And then if I type in custom RC4, then our custom transform is here. And then I need to copy. So we already know that that key is going to be used here. So if I go find that key again, let's just pivot off of this, grab this key. So I'm actually going to copy this with the null byte if I can, hopefully. And then copy bytes, right? Or is it copy as hex as byte string?
Yeah.
Okay. And then if I paste this, so this is like the same format as Yara, then we can see that we have this E8 output. So this looks like it could potentially be a instruction. And then if I scroll down,
peek, you can select disassembly, for instance.
Oh, cool.
Up top.
Oh, yeah, look at that. So call 5. So this is a very common technique that's used for shellcode in which it needs to acquire its current virtual address that it is executing in. So this call will basically jump ahead 5 bytes. So the size of this instruction. Oh, hey, Fixit42, thanks for the raid. Really appreciate it. How's everybody doing? So we're just doing a stream on this tool called Malcat with our friend Renaud here. So that's what I'm going over. But yeah, appreciate the stream, or the raid, sorry, on this stream. So basically this call is doing a jump over these 5 bytes. And then because it's a call, it's pushing the current given address from the call site onto the stack. And then when we do a pop, it will acquire that address that was pushed onto the stack for that call off the stack. So that's basically what it's doing there. And then it's doing this in EBX and then doing a whole bunch of different stuff. But what the shellcode is actually doing, so if I do a new file here, then we can see a whole bunch of different stuff. So we can see that the carved files contains a portable executable. So what was nice about that carving method is that effectively we had, yeah, exactly what Arsenal Apin said, that this is position independent code that is loading this given portable executable into memory and executing it. And what was cool about the file carving is we didn't have to look through all that shellcode, see what exactly is being used, and maybe using like dynamic analysis in order to determine if it's being loaded. This just carved out the PE for us, and we're like, okay, cool. So let's look at this portable executable now. So if I right click on this and then go to open a new tab.
And just a quick note for the carving algorithm, it works also on memory mapped files. So if you have a memory dump, it will be also able to carve the right P files and take everything into account that it's memory mapped.
Nice. Yeah, that's amazing. Because I always dump stuff from memory, and then it's kind of a pain getting it back into an unmapped state.
Yeah, you align the section every time. It's annoying. You don't need to. So.
Yeah, that's awesome. Okay, so then this is where Kesakode shines, right? So this is actually a plain text portable executable. So this won't always be the case where we would have a plain text PE at this stage, but basically it's just one unpacking step, and then it executes position independent code that loads and maps this executable into memory and then runs it. And we can see down here that Kesakode has an 84% match for Emotet. So say we were triaging this for a customer, a stakeholder within your company, whatever, and we had to identify this actual malware variant in order to do more research on it. Kesakode has matched that. Well, it has an 84% match for Emotet. So we would probably want to confirm this in some other shape, way, or form by analyzing this further. But in this case, we already know this is Emotet, so we get a match for it there. And then we get a bunch of different anomalies, again, for this particular portable executable, that it has an embedded program. I don't actually know how this one works.
It's not complicated. It will scan every car files, and if there is one of type program, then
I see. Okay. Big buffer, no XREF, medium, high entropy. It's quite the mouthful.
It's a big one. Yeah.
Okay, so a medium, so a 10K buffer, which is not part of the node structure, has our cross references aside.
Yeah. This is a good one. This one, if you want to spot packed data or encrypted data.
So that might be like the config or something. Oh no, there's another MZen here. Or no, that's just the carved one we looked at, right?
No, I guess that's also the P. Because look, it has, I think the P itself is kind of, if you scroll down, the entropy looks a bit high from the P's.
Oh, okay, so is that matching on, so is this, which one is Emotet? Will it only run Kesakode on the parent?
Yeah. Double click on the P, we'll have our answer. If you double click on the P in car files on the left, in car files, and just double click on this one. We'll see if we still have a match. Oh, I think that's Emotet. There we have 100%. Okay.
So this is probably...
I think that's an Emotet loader followed by Emotet.
Cool. Okay, that makes sense. See, even better. So we are able to not only find the Emotet binary, but also the Emotet loader in that particular instance, based on the functions of that are defined as Emotet. So that's what's kind of hard with classification in general, is that basically the malware family doesn't necessarily mean a particular module within the malware. It's not great. Malware classification can be difficult because when you're talking about different pieces of the malware. But obviously this worked for both the loader and the main module. So okay, cool. So I think that's basically all I wanted to go through today. Does anybody have any questions for me, Renaud? Do you want to look at more of the functionality in here? I think we can like build a Yara rule if people are interested in doing that, and we can look at a few different other pieces of Malcat. Okay, why don't we do that? Well, I see if folks are interested in seeing anything in particular. So if we go to, so within the main Emotet module, we have the, let me see, let's go to source code, and then it has the state machine, which is actually control flow flattening, which is kind of a more advanced topic. But I wonder if there's like an area of this disassembly that we wanted to create a signature for. I can just select a disassembled area and then create one. Is that correct? Or what's the best approach for your rule?
Yeah, as you wish. But don't start. You can either select the bytes on the left column or the instruction on the middle column, but don't select both.
Oh, I see. Okay.
So you're confused there. Exactly.
Okay, and then I can do magic mask, right?
Yeah, instance. It will just adapt the selection there. You can mask your selection in Malcat. It's used, for instance, if you want to copy the string into a Yara rule, or just search with mask, with a pattern mask inside your file or other files. So you will see it's used at different places.
Yeah, so if I right click on this, then I can do something like add selection to Yara rule.
Mm-hmm.
And then we want to add it to a new Yara rule. And then we'll do disassembly with mask.
Yeah.
And then let's just say this is for Emotet main module. And then we'll just say this is, suspicious is fine. And then you can set things like TLP and stuff, which is cool. And then I've set up a, oh no, this is going under the main data directory.
I think you need to create the file first.
Oh, it needs to exist already?
Could be, I don't remember, to be honest.
I'll just put test.
It needs to exist, okay. That's not true.
This is a pain. Hold on. Trying to do it from Explorer is a pain.
If you want, you can create the rule from within Malcat. Maybe it's easier.
Okay.
Easier.
Yeah, let's just do that.
Just close this for now. Cancel. If you click on the button in the middle on the left, you see in the middle of your screen there, left. Yes, this one. Click on this one. There you have a file browser with all your rules.
All right.
And if you click on the small user icon in this panel, there, this one, it should bring you to your user directory. There you are. And there you can click on the button on the right, create a new empty Yara rule. Yes, this one. My rules. Okay, so it's there. And now you can go back and add your code.
Okay, so yeah, we'll just select a portion. Obviously, this isn't a super comprehensive rule, but with these jump offsets, maybe it would be a decent Yara rule. And then we'll do add rule with magic mask, and we'll just say Emotet loader, or well, Emotet module entry. Okay, and then look at that. Automatic rule generation with masked bytes, which is really useful when you want to do triage and you just want to get a rule at the door, you want to test something in your corpus or whatever. Then another thing that we can do is if I go to disassembly again, I can mask these, which, sorry, I keep trying to do both again. Magic mask, let's see here.
Okay.
And then I can do search in other files, or how do I know that would just search it within the rest of the virtual file system?
This one, it's to search in your corpus of files. That's it.
Okay. Okay, so I have 3 different corpi.
Maybe I could explain a bit what it is.
Yeah, sure.
When you are creating a signature or just trying to identify malware, well, personally, I don't have a good memory, and I always, where did I see this pattern? Did I see it somewhere? So there you can just set up in the Malcat's options. You can set up directories of all the files that you have on your computer. For instance, you could have a malware directory with all your plain text malware that you have analyzed, but also a directory with clean files, because when you are creating a rule, you want to be sure that your rule doesn't match any clean file. So you set up your directories like this, and then using Malcat, you can scan anything, a pattern that you have selected, or a Yara rule, or everything. You can scan it against this set of directories.
So just to show you what I've set up here for my corpi, if I go to preferences, fortunately I didn't put in any API keys. I've just basically set the clean directory to system32. So we'd probably want to do, like, say I want to do a new one and just call clean x86, because this is a x86 Emotet, I believe, or was it 64-bit? It's 32-bit. So then we do like syswow 64, because obviously you're going to have different matches for 32-bit instructions. Then click OK. So basically so will it recursively descend into those directories?
Yeah. Multi-threaded also.
Yeah, that's great. Okay, so if we do search in other files, and then we search all of our corpi.
Yeah. It should take some time. And on the bottom right, you can see the advancement.
Yeah, nice.
System32 is big still.
And this is a VM, so it doesn't really have the best specs. Shadow EXE says, hello, everyone. Nice to see you here, Renaud. I don't know if you know that.
Hi.
Okay, so we got a whole bunch of hits on this, so this is a terrible rule.
Yeah, for instance, you don't want to use it in your Yara.
Yeah, so definitely not great.
And you can also search if you have multiple files open. You can search in all your open files. So if you are creating a rule for multiple samples at the same time, it's also useful.
Oh, nice. Yeah, that's awesome. And can you open a directory of files in Malcat or no?
No.
Okay.
No.
Okay. Yeah, I think that is everything I wanted to cover. Does anybody have any questions, or if they want to see anything else, or have any questions for Renaud?
Yeah, don't hesitate. I mean, my English is terrible, but I can understand you. Don't worry.
I don't think it's bad. Very cool. If nobody has any questions, we could probably wrap it up there. Thanks so much for joining us, Renaud. Really appreciate you.
Thank you for the invitation.
Helping me with
really nice.
learning Malcat and then checking out all this really cool functionality. I think it's a really useful triage tool. I'll probably use it again on stream and see what else we can mess around and do with it, just because there's a lot of really good, useful built-in functionality. Oh yeah, one thing I wanted to show everybody is in that, so like it even has a whole bunch of built-in Yara rules in addition to the Kesakode stuff. So like if I go to the Yara scanner, so like if I go under here, like all these Yara rules are built in. So it's really useful for...
But you won't find any malware rules. It's by design, because first I would have to maintain them, because malware evolves, of course, and I don't have time for this. And also, I mean, everybody has different likes and taste in malware detection. They are just suspicious rules. So just, again, they are pointers for you, and you, at the end, you have to decide yourself, is it malware or not? And if you want malware rules, just add your own. That's you will just find suspicious rules.
Nice. Yeah. Oh yeah. So a couple of things I wanted to announce. So I will be at DEF CON next week. If any of you are free on Thursday and will be attending, we're going to be doing a meetup Thursday afternoon. So I will shoot out another reminder on our social media and in our Discord. So just make sure to check out it at Invoke Reversing on X/Twitter or on Blue Sky. And then we're on LinkedIn as well if you use LinkedIn. And then if any of you want to come out, meet me in person, we're going to have a bunch of swag and stickers and stuff like that for Invoke RE. So just wanted to say that. But yeah, really appreciate you sticking around, Renaud. Hopefully we can have you on again to look at some advanced features like what we were talking about at the beginning of the stream, because I think that would be really cool. And I like talking about advanced obfuscation techniques as well. Yeah, hope everybody has...
Happy to.
Yes, that's good. Yeah, thanks everybody for joining. Really appreciate you sticking around. And if any of you have any questions, feel free to reach out to me on social media.
Yes, thank you guys, and don't hesitate to give it a try. Like I said, the free version is really already pretty mighty, so just give it a try.
Yeah, I think that's everything. So take care, everybody. I'll catch you next time. Probably be streaming
again
after DEF CON, but really appreciate you all hanging out.
Yeah,
take care.
Have a good time at DEF CON then. See you.